Hello and welcome back to the development of the Feersum Scheme compiler. So, in the last stream, we kind of got to a point where libraries work. So, I will find an example. We have this libcaptures, which we were working on making work. In Scheme, we have this define library, which takes a library name and a list of declarations. And this is probably not the best example. We have libgreet, maybe? There we go. This one's got export declarations, import declarations, and begin blocks. And the way that our compiler now works is that every time you make a define library statement, we compile all of the inner parts of it into a new .NET class. Then when you reference the library, so here we import the library, so we're importing some part of test greeter. When you reference the library, we initialize it, and then we can reference things that are in the library. So let's start as usual by going over what happened in the last stream. Mainly, it was about some work in the compiler about how we structure types. So at the root level, we have when we start compiling, we create a root emit context, and then we emit a script body into that. And what we did is we added a second way of creating a type definition. So here we have this. We have a second part for find type. Emit library. And in emit library, we create a separate type declaration and another root emit context. And this is very similar to the root context that we use when we are compiling a whole program. And this time we emit a named lambda, but this time call it library body. And then we have this context initializers list or map, which is where we store a reference to all of the library initialization methods so that we know when you import them later on which ones to call. So that's how we emit types into their own place. We also have in the binder, we had some special work in the root scope, because at the moment we have support for defining your own libraries. If I go back to that libgreet example, there's an import scheme base declaration because libraries start out without anything in their namespace, so they're blank. We've got a bit of a hack going on in that we don't have the same for the outer scope because we're treating it as a script. So in a script, we've said you don't need to import scheme base, it's just there by default. It's as if you're typing at a REPL. But that meant we needed the ability to import scheme base and get all of the methods that we have defined. So scheme base is effectively the standard library, and that is defined here in this assembly. So we have things like string methods, and we have annotations on each one of them to say this is the name that I want this method to be bound to. And then each one of these becomes a special kind of symbol, or as we call them in this compiler, a storage ref. So we have a special kind of storage ref for built-ins, which just contains the name of the built-in, which is different from globals, which are a pair of the library name and the symbol name inside that class. So what I had to do to be able to get scheme base to work is that when you create a new global scope, we kind of just fudge scheme base by fabricating a library. So this pair here of a list of strings, which is the library name, and a list of pairs, which is the contents of the library, or the exports as we call them, is effectively a library. What I'd like to do today is that same type appears in a few places. So here it is written out. It's a string list. It's a pair of string list, string, storage ref. So that is kind of a bit of a mouthful, and ideally we'd have a type that represents this. It'd live in our libraries code, and we'd have the ability to manipulate them. And I would like the ability to properly annotate these as being in scheme base, because not everything in this built-ins will necessarily be in scheme base. And at some point in the future, I'd like the ability to reference other libraries, because ideally you'd be able to compile an assembly, a .NET assembly, using our compiler, and then reference it to build another assembly, which would mean we need the ability to annotate all of our compiler output. So at the moment, if I run the tests to get them to actually build, and we can take a look at what ILSpy shows. So ILSpy command show IL for spec bin libgreet dl. In fact, let's not IL it, because we don't care about the IL itself. We could just care about the structure. So let's get ILSpy to pretend it's C#. That's a bit more readable. So what we see is that we have a class called list program, which is where the body of the library is. So in here, what it's doing is it's calling this script body in the main method, and then it does a bit of manipulation to create an exit code. And inside the body, we've got this undefined, which is discarded, which is the definition of the library. We've got the call to initialize the library when it's imported, and we've got a call to the greet method. And inside this test greeter, we have the body of the actual library. So let's go have a look at that. So that is this. We've got a call to display with hello, a call to display with person, and a call to display with an exclamation mark. And then the write out to the new line. But none of these classes have any real metadata that would allow us to work out that this property here should be exported and treated as something that you can import, or like to know that test : greeter means that the class should be treated as a scheme library and can be imported later. So that's one thing to do. But just to start things off, I was thinking we could try and write an example of something slightly useful that actually uses our library support. So what I thought we'd tackle is writing something that can display dragon curves. So the current support in the library, in our compiler, we don't have anything that would be able to display anything. But what we can do is we can produce something that Python would be able to use. So if I do Python and then I do import turtle, and then I can do turtle.show turtle, I get this window which can be used. And now if I do turtle dot forward 100, the whole thing moves and draws a line. So the dragon curve is an iterative fractal like thing, which is basically just made up of lots of straight lines and curves and turns. So let's start by defining a library. I'm going to call it dragon, and we will import scheme base because we're going to need it. And we will export dragon because that's going to be the name of our function, and we will begin the body of our library. So the inputs to our function will start off with the, well, what we want to say is, since this is going to be like it's a fractal that's iterated down to a certain level, we'll just take the number of iterations to go to. And for the time being, we will just display iter, and that's it. Then we can import dragon to bring the library into scope and call dragon with 5. So we'll try and go to 5 iterations. I'll just exit out of this terminal. So the way I'm going to compile this is I'm just going to run the compiler, which is in source fearsum bin debug. We will spec dragons is the input, output to spec bin. And then if it works, we will run it. So we do .NET spec bin dragons dl. That's not worked because that needs to be a directory. What has gone wrong there? I was expecting that to actually write out 5. But no. Off to a good start. Spec bin dragon. Call object script body. That's the main method. The thing, script body. Undefined get instance. Oh, I've just not saved it. Five. So what we want to happen is when you try and do dragon, the first thing you want to do is if we go back to what we were doing up here, we need to do some initialization. So we need to import turtle and we need to show the turtle. So what we'll do is define an initialize function and call that. This is going to be private to our library. So to init, we display import turtle. Then we display turtle.showTurtle. And we're also going to want to do some epilogue stuff at the end. So I'm just going to make or finish, finalize. Because if we don't, the window won't stay around when the program exits. So what you have to do is call turtle.done. So if we run that again, great. Who was expecting display? Because that should be new line. Now we should be able to take this and pipe it to Python. And we have a window with the turtle. So now all we need to do is actually implement the dragon curve iteration. So we're going to make a function called dragon iter. And we'll pass in our iteration count. So that's going to take iter. And if we go back, what we want to produce is, well, the first step is just, if we think of it, is just a line. And then each one of these, so each one of these then gets a turn in it. So in the base case, when iteration is 0, we just want to go forward. So if iter is equal to 0, then we will display, we need to do a begin block here because we're going to do several different things. We're going to display turtle.forward. Then we're going to display 10. And then we're going to display that and print a new line. So now if we rerun it, we should see, it's not a very long line. Let's make it 100. That also isn't a very long line. I'm starting to suspect, because we don't have any iteration going on here. So let's draw the dragon for 0 first. There we go, and we have our line. So the next thing I want to do is here what we're doing is we're calling this specific command forward with this parameter. So I'm going to extract that into a method because I'm going to be doing a lot of these. So we do display turtle dot display command. Right, we can break these over multiple lines, I think. Opening brace, the argument to the command, and the closing brace, and then a new line. And we can replace this begin block with just a call to command. Command is forward, and the argument is 100. And if everything goes well, that should still do the same thing. It does. So if we aren't in the base case, what do we want to do? If we aren't in the base case, then what we want to do is go, there's two different cases here. So if we aren't in the base case, we want to go forwards and left. And this one again is the first thing we do here, which we go forward and left. But this is actually like one iteration further of this tiny line that is half grayed out. And then we've got one which goes forward and right. But if you look at the overall higher up thing, it is forward and left. So every time we're going forward and left at one iteration, we can do that by going forward and left one iteration further down, and then turning left, and then doing forward and right one iteration down. And then if we look at how we do one forward and right one iteration down, we do that by going forward and left, turning right, and then doing forward and right one iteration down. So what we work out from this is we want to take a second parameter here, which is the direction that we're going to turn. And we will start off by turning because we see that the first iteration turns left. And then what we want to do is if EQ the left. So if we're turning left, do something. Otherwise, do something else. And we know that if we're going left, we can do a left by doing a forwards and we could do a left turn by doing a forwards and a left, followed by a left turn, followed by a forwards and a right. So that is going to be a dragon iter. We're going to want the next iteration. So what I'm going to do is I'm going to do a let next as -1 iter, sorry, minus iter1. So take 1 away from iter. And then let's move our if inside. Get rid of these braces. So what we do the next iteration, and the direction was first we go left, then we go right. And in the middle we do command left turn, which is LT, and then 90 degrees, because we're turning 90 degrees to the left. When we're going right, we do that. So this this here is a right turn, and that becomes a left turn followed by a right turn. So a left turn, one iteration down, followed by a right turn, followed by a right turn, one iteration down. So really, that is this. So that's iteration 0. Let's try iteration 1. Oh. Terminal focus, please. Okay, that's looking good. So the first iteration is going forward and then left turn, which is that. And then we can go one level further. Well, let's go a few further. Let's go up to 6 and find out what happens. It went off the screen. That's what happens. So what we can see here is that we always do drag an iteration at the next to the left, drag an iteration at the next to the right, with a turn in the middle. So what I'm going to do is I'm going to move the if inside the begin, and we could probably actually, because all we really need is that LT. So what we could do is we could define another variable. So we can have turn command, and turn command can be if the direction is left, then left turn, otherwise right turn. And have I got the right number of brackets on that? Then we don't need the begin block. We can just use turn command here. Like that. Looking good. We still got the problem of scale though, because as we go deeper and deeper into this set of iterations, so if I take this up to like 10, because we're always going forward 10 each time, we're just going to end up driving off the end of the screen. So what we have is, if we have a unit here to here, what we've really got is 2 right angled triangles. So at each iteration, if you say that was 1, these are actually √2 long. So what we need to do is take a size in as well. So size is going to be how big overall we want this whole thing to be. So when we call drag an iter, we can start off with a size of 300. And instead of going forwards 100, we can go forwards for the size. And then each time we iterate down, instead of calling dragon iter with the current size, what we'll do is we'll make the current size smaller by √2. And I've taken the wrong bracket there. Size, we can just reuse size because it's a scheme. So we take the size and multiply it by √2, which is 0.70711-ish. Doesn't need to be that exact. And now, hopefully, yeah, we need to pass in size here, and we need to pass in size here. And size, and I've misspelled size. So now it's smaller. Going to do a few things to speed this whole thing up. First one is we can speed up the turtle. Ten is the biggest that the speed goes. And I think we can also tell it not to trace, so it doesn't animate the whole thing. And what we could do, we'll leave it. I was going to say we could turn this and this into a call to command, but go on, let's do that. So instead of that being, this is command speed 10. Tracer. We need to use a string because this is Python's false. And it's not printed out the same way that Scheme's false is. And then for this one, I think we can just do show turtle and the empty string because we're not doing anything particularly fancy in our command function. Boom. We can make that a bit bigger. So instead of 300, what we can do is if we rotate, we can see that the whole thing is going up in this direction. But if we rotate by 90 degrees, we've got a bit more lateral space. So if we do command right turn 90, yes, because it's called command. It's actually gone. Look, we've got arrow locations. Let's click on it and go there. Got to use the features. Hey. Hey, see, F# is good. Continues to be functional. I think we can make that bigger. We can make... Oh yeah, we didn't actually make it any bigger. Let's do twice the size and see what happens. Looking good. What kind of functional programming have you done? This is taking a bit longer. This is just running our program. It's taking longer this time because we've done 20 iterations. And this is a very recursive algorithm. Wait for it. I hope it's worked. Maybe broken it somehow. Let's try running the executable and see what the output is that we get. .NET spec bin dragons. Oh, you've just learned some functional program concepts. Functional programming is quite fun. It's more like instead of thinking about classes and classes calling methods on each other, you're thinking about objects and mapping them through functions. But F# quite a pragmatic language, so I think it might just be that this is taking its time. It looks to me like the output is correct here. I don't know what. Let's try. The window's not responding, so that's always a good sign. Let's just try running it again. Yeah, F# tends to be quite pragmatic in that because it's running on .NET, you can just define classes as well as defining functions. Yeah, that's not working. I think we've just had too many iterations. Let's go for something a little bit easier. I suspect it's actually maybe Python that's not happy. Yeah, so 15 we're fine with. Unless it's not that it's just getting too small to be able to see, is it? There's a bit of a pause. And we're going off at an odd angle. Ideally, we want this to be going this way. So I think the problem here is that if we go back to this example, we started off in this direction, and then every time we go one iteration further deep, to keep the whole general thing going left to right, we need to go 45 degrees right. So this isn't actually right 90 degrees. It is 45 degrees times the iteration count. What else should you know about functional programming? I don't really know. I mean, it's popular. It's different from... I guess one of the biggest problems you can have if you're writing programs in a functional style is if you have experience writing in imperative or object-oriented styles, then you can often bring along the baggage of those styles. And the same thing going in other directions. Like, you can always see people who write for example, C++ as if it was C, because they're thinking in terms of C. Whereas if they embraced objects, they'd write more idiomatic code, and it becomes both more maintainable, and also sometimes if you just follow the idioms of the programming language and platform, your code ends up faster. And like if you've got runtime and you do the things that people expect you to do, then you'll fall into paths, happy paths, which are optimized and that kind of thing. So yeah, I'd say just generally, as with anything, if you're learning a new programming language, it helps to have a good problem to solve and then try and come at it with an open mind. It takes a little bit of time to just learn how to think in terms of, mainly, I think the two key things that you can do with functional programming is like mapping functions over lists of things, because lists are pretty big, or sequences of some kind. So yeah, mapping functions over lists of things, and recursion. So like, let's go have a look at some example scheme codes where I can talk a bit more about recursion. And in the meantime, I will decrease this to a slightly more sensible level. What are you doing? Nothing. Finalize. We do turtle.done. Do we need to do turtle hide turtle? Maybe. Nope. And I guess these could also be calls to command, couldn't they? Speed 0 also sets it to the fastest speed. I'm just going to try that. It worked better with a bigger number. I don't understand that. If we go, what I would like to do is I would like to check this code in, and if we do a spec test, why is 5 bad? What are we getting out here? I mean, that looks fine to me. I think, is it this? Nope. I was wondering whether or not the turning too far was ending up being a problem. Let's do it again, but just at 0. It's curious. It's definitely something going wrong in the way that Python code's working though, so I'm happy to just use a low iteration count and check it in. So we will generate a snapshot from that. Most of our imperative code do HTML, CSS, JavaScript, PHP, SQL, and Python. That is a lot of different things. Work a lot with databases. I'm building a compiler for the Scheme programming language. At work, I get paid to write C#. I write C# in my free time as well, but have experience obviously writing F#, writing little bits of Scheme. I've written Rust. I've written C, C++. I've been paid to do that. I've done some assembly language, doing embedded systems, and also just building operating systems. I've written Python as well. I've written even some BASIC a long time ago. I've written a bit of PHP back when I was at college. I'm not necessarily up to speed on every single one of those languages right now. I even wrote a little bit of JavaScript. I try not to. And SQL is another thing I try and stay away from a little bit. Not necessarily. It generally, SQL just means you're working at a layer of abstraction that we don't usually deal with at the moment. But it's very useful to be able to crack open SQL console and see what's going on. So. Right. Let's go over what we've done and see about staging it. So parsing for dragons, the output of the spec tests. I mean, it's long, but it's not the longest thing we've got in here. And the code itself. Let's just run the tests. What kind of databases have you been working with? Have you worked with any NoSQL databases? So back to the actual main task at hand. First thing I wanted to be doing is extracting this type, which is the pair of library name and library exports into its own type. Okay. You haven't done NoSQL. I mean, things like Elasticsearch were really big for a while, and I think they still are to a certain degree. But I think there's also a whole raft of newer database technologies that are SQL-ish that have come about again. Also, key value stores are pretty big in terms of stuff that we use. So things like Couchbase and that kind of thing. I mean, sometimes modeling relational data as relational in a relational database is the way to go. So let's come up with the type. So this is kind of like the signature of a library. I can't really come up with a better name for it at the moment. It's kind of like the API surface of the library. We'll go with library signature. Do we have I imported libraries already? in this? No, I haven't. I think we are fully qualifying at the moment because something in libraries in this module clashes. I can't quite remember what it was. It probably just needs dealing with, but that's not a stream thing to do. So type library signature is, and we'll make it a record. It's going to have a library name. In fact, it's going to look very similar to the previous one. The difference is that this is the output of define library. So this is something we've passed, and the library signature is something that we could have got from metadata in an assembly, and it doesn't contain the bodies, it just contains the exports. So string list, which is the library name, and exports, which is a, well, I copied it, so I can paste it. We don't have storage ref. Let's move this into the binder for the time being. So it's not really because I think, yeah, storage ref's in the binder, so we need that in here. And then I can just reference the library signature. So that's that, and it's just a matter of finding all of the places and getting rid of the red squigglies. So library name is that, and exports is that. I mean, we're still leaving that hack in for the time being. Context libraries. This. We can build up a new library here. Signature is library name. Just name. Exports is exports, and then we just paste that on instead. What else? Forgot. Resolve import. I see. So this is in libraries, but the way this was working was because it's actually doesn't care what the type is. So I think that might be the pointing us into the way of the solution here. So library signature actually wants to be library signature A, and in here instead of storage ref we can do A. Then in libraries we can bring this back. Binder, that's going to be a library signature storage ref. This kind of mimics what's happening with scope as well, where we're just passing in. I mean, scope doesn't care about what's being stored in it. A library signature also doesn't care about what's being stored in the library. And that must be libraries dot library name. Libraries dot export. So it's libraries dot library signature. This is sort of awkward, but it works. Same thing here. Just paste this onto the front. I mean, we've done that in 2 places now, so maybe we should make a method. Have you seen closure? I have seen closure, but I haven't really tried it in anger yet. There's also Racket, which is a scheme style program language as well. I believe that can be refactored later. So now we're passing the libraries in. We can fix that up. Oh, they're just both calls to resolve import. So in resolve import, libraries is expecting something that can be is a list string something pairs. And why is it thinking that? Because somewhere in here we must match on it. Here. So seek, try, find. We change this to signature. And then do signature.library name. And instead of this, we do some signature.exports. That should be enough. Here it has... we're just expected to return the signature itself. Fair enough. I mean, think this is effectively just turning an option into a result. What are you unhappy about? Something else list. But why? Probably because of how we use it. This is what happens when you don't have enough type annotations on your functions, and we're relying entirely on type inference to type it all up. So map, import library. Okay, so now import library, is we want to do library dot exports and library dot library name. Need to type it in some way. We use now it's a signature storage ref. So that might work. I'm just going to compile it to make sure that we aren't looking at red squigglies from a while ago. Is scheme prefix notation? Yeah, so the way that scheme tends to... look at all of that. That's not nice, but we'll come back to that in a while. The way that scheme tends to look is that you have all of these brackets, and each one of these is called an S expression. So an S expression is an opening bracket, a list of things, and a closing bracket. And the things can either be atoms or S expressions. So in this case, command is an identifier, which is an atom. This turtle is a string, which is another atom. We've got numbers, and I mean, really, that is all you're seeing here. Oh, and symbols, which is a quoted thing. So if you quote an identifier, it becomes a symbol. The little tick just means that the whole thing after it is actually quoted. So that means rather than this being the defined dragon, this is now actually just literally a list that contains a symbol and then another list that contains a symbol, blah, blah, blah. So programs are data in Lisps. And there's not really a huge amount of syntax. It's mostly in like how you interpret these lists of things. So if we take a look at like Emacs also has a Lisp that's built in, but none of its let's see if I can find an example. So Schemes Lisp looks the same, but things like we've got require instead of import, we've got define instead of define. There's also semantic differences in the way that symbols are looked up, but generally schemes look the same. Lisps all look the same. Scheme is a type of Lisp. There's a certain amount of like chasing the purity about the whole thing. More modern functional languages have taken a little bit more syntax to try and make your life a little bit easier, but one of the advantages is that whenever we're doing work on this compiler and we need to like recognize a new form, we don't need to do anything special in terms of parsing. So usually we start in the binder where we have a big switch which looks at all of the different case labels. So if we are looking at a form that starts with import, then we treat it like this. If we're looking at a form that starts with quote, then we treat it like that. Whereas if you were adding something into F# and you wanted to add a new thing for import, you'd actually have to start parsing. And say, like, if I see an identifier and so. Right. What are you? You're upset about? This is... Okay, I think that is... No. Bound expression import of string. So it's expecting to... It's expecting... Import library is expecting a binder context and a library signature. So what's going wrong here? Okay. So the resolve import function has got is getting a bit messed up. So I think it's because of this map exports function, which is supposed to take a library signature and map the exports. That's what it's supposed to do. And we didn't update it. So we have a signature and we do signature with exports equals signature.exports remapped. Now, does everything compile? No, I can already see a knock on. Oh no, I think that's the old squiggles. New and different errors? Oh, from the tests this time. Because we are testing resolve imports. Because these things need to be import expected ID expected. So if we take signature, and then this would be, I need to let this is signature dot library name, and this is signature dot exports, and I've capitalized the wrong thing there. And now libraries is the only thing that's wrong, because this needs to be a new library signature, which I think we might just be able to get away with doing library name and exports. And that hopefully isn't ambiguous. I've taken too much there. So that wants to close off that tuple like that, and then be happy. Complaining about typing compatibility, so pretty certain it's an old error. Again there. Come on, compile those tests. Great. And let's run them. Now, we want to have a look at the bit in the binder where we hack things together. There's a fix me for it as well. So this is taking the scope and turning it into turning the scope into a list of things and then importing them. So I guess what we can do is let's find out how many places call create for global scope first, and then we can refactor create for global scope so that we can pass in a list of libraries. So there's the declaration. Bind library creates a global scope with an empty map. So that would be fine because we can do an empty map. And What do we want to do for libraries? Behind the context. How is that actually working then? Ah, because imports are resolved in the outer place. But we can pass in context.libraries at this point. So we can pass in that. And here at the root, we can do our hack out here for the time being. Maybe. Then in here we do our libraries list and just stick that in there. Is that gonna all compile? What I'm trying to do is just push that high enough up that we can pass in a list of references. Find the type string. Where are we talking? 615. Oh. Because I've got them the wrong way around. We need our list of libraries and then our list, which is the program name or library name. So this here is defining a scheme library called list program. It doesn't really matter because you can never import. Ooh, can you? We'd never put it in any list of libraries, so you'd never be able to import it. But what does matter is that gets mangled as a library name, so we end up with a C# class called list program, because over in the eval code, we hard code that when you try and evaluate something, we compile it down and then look for the program type. And then the question becomes, can we pass something in to the binder that represents the list of libraries? So where is bind coming from? Well, where is bind used? We only use it in one place, in compile. So compile gets given an options, which I think is probably where we're going to want to store these referenced libraries. What do we have in here? Do we have? I'm trying to. So we have the built-ins. Do we have the built-ins at this point? Got IL helpers. So in F#, things are evaluated, or your source is all in a specific order. So in compile, we should be able to reference the built-ins if we need to. And built-ins can reference libraries. So compile, what do we want to do? Let's go change the options first. I'm going to do some command line parsing here. No, let's not do that. Because it'd be nicer to just maintain the current behavior where we only reference the stuff that comes from built-ins. So let's call lib equals so you got built-ins at core types. Built-ins load core. So load core takes an assembly that it imports references to. So we got core proc names. So I think core proc names and core macros, these are the things that we want to get rid of, and instead we should probably have like a load core signature instead. Built-ins. Problem is that built-ins are before bind. So we don't have reference to, I think we could probably just move them down. I think what we might need to do is move the symbol stuff out of bind into something shared more widely. So we have storage references that you can reference from these other F# modules. So load core signature is going to return library signature. Let's just call it library name is going to be scheme base. I'm not entirely sure about spacing on that. And exports is going to be this needs to be storage ref built in. This is going to be seep.map. Actually, we can just do storage ref macro here, and we end up with a sequence of macros, hopefully. And then the exports. So these want to be pairs of because we want to be able to use them to build up our library signature, and library signatures take those pairs things. So this needs to be, instead of that, it needs to be a function that takes a macro and turns a pair of the macro name and structure of macro, the macro. And then this can be list seek dot concat core proc names, which is badly named now, core macros list of seek. What are you upset about? It's library signature. Let me just open libraries as well. Value is not a function and cannot be applied. Okay, so that needs to be append. Yes. So if we make these both private, and we just have load core signature that returns a library signature, and load core, which really should be like called import or maybe just import core, because this is functional programming and we don't do long names. I heard a lot of F# features were added to C#. I don't really know how true that is. I mean, a lot of F# features are just reinterpretations of C#. It's just syntactic sugar for doing things that you could already do. But there's definitely things like pattern matching that are really powerful in F# that just generally are starting to become more widely known, I guess. Because so things like Rust have pattern matching and various other languages that support those kind of types, and that kind of programming is becoming more popular with things like switch expressions in C#. What are you upset about? Well, how about that instead? So then we take the core library and we pass that in like that. Then we take this and have it take our libraries instead. And then we're separating out the root scope from the list of libraries, which is a good thing because we don't necessarily always want those to be the same thing. So create root scope. I mean, at the moment, it's going to do the same thing, I think, isn't it? It's going to do built-ins dot load core. I'm going to take the exports. Herein lies the problem. The binder no longer has access to the built-ins. How about instead how about we just make the root scope from a library? Where do we call here? Core library. Then are you happier? Maybe that's happy, and that's back to compiling. And we could even go as far as taking a list of libraries and importing all of them by default, but we'll leave it at that, I think. This probably create root scope. How many times are you used? Only here in compile. So I guess go on scope from libraries, and then we can take lib as being a sequence of library signatures, and we can turn it into, we can do libs Pluralization is important. Seek.map it. Take all the exports, then concat, I think. No. F of x into seek.collect. I mean, sure. So take the libraries, collect all the exports, and then turn it into a map. Good. Let's run the tests, make sure we haven't broken anything. We have broken something. Doesn't even compile. Yes, because that wants to be, well, what can we, I mean, we can give it a list. But is there like a seek.yield or something? Oh, there was already a C there, it was just hidden behind my cursor. Half of being good in any programming language is knowing all of the different library functions, but this is the modern real world, so we don't have to. We just have to search. Guess it would be called seek.yield or seek.return. I can copy and paste over here. So we have all pairs append average cache. Cache? What's that? Sequence that corresponds to a cache version of the input sequence. Not sure that's what we want. Choose. Collect. Seek.delay is a way of preventing execution of an iterator until some point in the future. Seek.empty, exactly one. It's like an unwrap. Filter, find. We're not folding. Nope. Last length map. Pairwise. Is anyone shouting at me? Nope. Scan. Singleton. That's it. Okay. I knew there had to be some way of doing this. So we can do seek dot singleton. Call it instead. I mean, it's kind of almost exactly the same, but we had fun. So the tests are happy. we've now separated out producing the scope from produce and doing the bind. So what we can do is, well, I'll go through what we've got, commit it as soon as everything works, and maybe change the behavior of the compiler so that we respect the scheme specification a little bit more. So I was discussing the fact that we're always importing scheme base, but in theory, you're only supposed to do that if someone is at a REPL. If they've got a script file, then they're supposed to be required to import scheme base. Compile. Yeah, so we got that changed to the way that we import core. We've got the libraries, and so I guess it is pass libraries bind. Bind now expects list of referenced library signatures. Auto. So in compile, where we're building up the scope, what we could do is say if options dot, be very interested to find out what this breaks. No, that's that. Options dot output type is output. If it is a script, if it's a script, then we import it. Otherwise, empty scope. So I imagine this is going to break a lot of things, but hopefully it should be a fairly simple fix to actually force to just go through all of the all of our spec source and add an import scheme base. I think the more difficult ones to fix up will be when we need to fix up unit tests that aren't doing the spec style tests. So I don't know if there are any of those. So 30 failures, only 30 failures. That's interesting. Because I mean, some of these tests are actually passing. So let's just go through and add. Import scheme base. So user macros. That's using display and list, so it needs it. Tail call. Yep. That needs it. Symbols, doing display, that needs it. Definitions. Strings, that doesn't need it. It's just literals. Using display does. Quick sort, definitely needs it. In fact, though, we can show off the fact that we can import more than one thing at the same time. So we can do import scheme base here. Parameters. Nope, doesn't need it. Null doesn't need it. Locals. That uses display. Isn't there anything else? So let's do import scheme base. In fact, I'm going to go back and copy that because I lost it from my clipboard. Try to work out whether or not it's more useful to have the trailing new line or the leading new line. Load and store. That's not doing anything interesting. That's not doing anything interesting. Lists. Yep, we're going to need it. Libraries. I mean, yes. Ooh. Yes. Yes, we are, because we import display. Test greeter. Lib capture. Yep. Display. That's just doing lambda evaluation. Factorials. Yep, we want it. Display. Display. That's doing stuff about captures. Fact. Again, display. That's not the first factorial we've seen, is it? Oh yeah, because it's a fact. Oh, the sieve. This is a prime sieve implementation. Wrote a while back. Equivalence. Yep. Dragons. We're definitely going to need it. Oh, are we though? No, we don't, because we import dragon and dragon does the printing. Scheme base. Define and assign. Yep. Conditionals. Nope. This is all about comments. Also about comments. Characters. Yep. Wow, there's a lot of stuff in there. I've written quite a bit of tests. I'm impressed. Capture test. Again, we've got display, so we need to import it. Byte vectors, display. Built-ins, we're close. Built-ins doesn't do anything interesting. Built-in macros does. Booleans, I was hoping that it was not going to have any, but there you go. And begin. Begin is just begin box. And then in fail, macro fails, that does use list, so we'll import it. Bad strings, nope. Define libraries, not doing anything interesting. Bad imports, not a real library. And that one isn't doing anything. No, set is a... It's not actually a function, it's syntax. So if we run... Well, what have we got? Let's stage everything. Oh no, we got... Let's stage the compile change. And then update the snapshots and see what changes. Because hopefully none of the output will have changed. The only thing that will have changed will have been the parsing. So all of these parse things are fine, but looks like the output has also changed. Why? Macro fails has changed. Well, okay, so that makes sense. Some of our diagnostics have changed position because I've edited the source, but that's fine. None of the actual ways that the programs have run has changed. So we've not got exit codes changing. We've not got new output or missing output. We've only got these 3 changes to the 3 spans, all in the same file by the looks of things. So that's fine. Macro fails. Ah, I see. It's just the way that we're constructing the test. The path is bad for these parse failures. It's putting parse underscore something, and then the something's got the path separator in it rather than. So we end up with a directory called parse underscore fail rather than a parse underscore macro fails in the fails directory. And I guess all of these are just going to be changes. Oh yeah, because every single one of them is going to have a new span at the beginning. I think we just got to accept it all. And then say require import for non-script files. That's a really bad commit message. Don't implicit port base for x's. X. Going forwards, we might end up kind of auto-detecting whether we think it should be interpreted as a script or a hard executable based on like what the extension is. So all of our spec tests at the moment are SCM, but there's actually a few different like scheme extensions that some of them mean this should be treated as a library that someone's going to import at some point, which is something we'd think of something to be compiled, and therefore it should be a library. And some that mean this is a script that you would expect someone to run. And why have 3 of the tests failed? That's not great. I was just compilation error in the built-ins. Reference to undefined symbol. I've missed something, haven't I? I mean, it's testing the built-ins. So I should have worked that one out. What else have I got? What else have I missed? User macros. Reference to undefined symbol new line. I just hadn't scrolled up. Wow. And one more. Locals. So although it doesn't call display, it does use the operators, which aren't built-ins, they are methods. I mean, they're built into our core library. So let's update the snapshots again and squish that down and pretend it never happened. Hello? Surely you must pass differently. Ah, there you go. He's just taking his time. So I guess what we next want to start looking at is marking up library names on things. So I'll do that and then I'll call it a day. So we already have this attribute which we use to detect where built-ins are supposed to be from. So that is in, oh, it's not in tests, it's in the source. Lisp built-in attribute. So I think what we want to do is add a new attribute for Lisp library. And we will Lisp, no, Lisp library attribute. It's going to take, I'm going to make it a string array because I think it's going to be easier because we are going to end up wanting to emit these in IL as well. So name, it's just going to be a list of strings and we'll set name to name. Nope, what I wanted to do is do this, public string, we can make it an IEnumerable. Now, I read only collection string name, which is a get only auto property. And then a bit of XML comments, which I'm just going to steal from the built-in attribute. Oh no, it doesn't have any. Attribute to mark. Don't really know why we're using Lisp attribute and it's a scheme library. We'll find out. We don't really need. We do. We do want a dot comment here. At some point, I would also like our compiler to omit documentation. So when I compile this, actually, it's a good question. Do we have documentation even turned on? Nope, not there at least. Maybe all the way up at the top. No. Let's of a new file. Because I want to show how docs work. So you set generate documentation file to true. That tells the compiler to emit some XML files next to your assembly. I think that needs to be a backslash. Let's try building. Attribute include. Nope. What is it? Maybe it's not reference. Import project equals. Got there in the end. Is that read only? Like that. I think it's in system collections generic. It's capital O. I think I need to restart OmniShop. We want to ignore these CS1591s because they're just going to be all over the place. These are actual errors. Paramra Camarata. Yeah, well, that's not quite right, is it? Uses a dot. Methods to interact with Scheme. Our Scheme vector implementation uses the .NET list. Is that? Or is it that? It's that. Given there's still a blue squiggle here, it might be alright to just go like this. Yeah, restart the task. Back on track. This wanted a summary attribute. The library's name. And then what we can do is we need to set an attribute target on this, which I don't remember, but copy and paste. So this wants to be targeted at class. Whoop. No. Why are you not? Oh, because you know what? System. Is it system dot reflection? Or just system? Okay. It's not an attribute. This compiles, I think it is. That's all we need. That wants to be system collection generic or just list T. This can be a Lisp library, and this wants to be like a string array, so has a cat. Can I do scheme base? Is that going to build? Then it'll be some busy work for me off stream to go through and mark up all of these with the correct libraries, because some parts of the scheme standard library aren't actually in scheme base, they're in like scheme list and that kind of thing. There's even one that is just for all of the helpers for accessing parts of a cons path. So we've got list methods here, and we have like cons, and we also have car and coder, but there's also like CADR, which gets the address from the data part. So the left hand side and the right hand side of the pair are called address and data part, because boring old reasons. So you can like nest these quite a lot. So you can, as well as like car, you can actually have like CAR and then get, or like CADA, or I don't know. But they aren't all in the scheme base library. There's a special library just for those. So we'd end up probably defining those. At some point, it would be nice to be able to compile some scheme of our own down to be this base library instead of using C#. I think we might end up there sooner rather than later, actually, given what's happened over the last few streams. So the one last thing I was going to show was documentation. So in the bin folder for Feersum, we now have fearsum.xml. So all of the comments just end up in this doc So you have an assembly that tells you the name of the assembly, and then you just have a lot of members where it says member name, the name of the method. This is all F# generated code, so the names are a mess, but then you just have your summary text. So this is stuff that's come from C# and it's a little bit more structured because we've got param ref and stuff like that. But it'd be nice if you could use doc comments in your scheme and have the same files generated, because then that means that when people are like either decompiling your library or trying to generate documentation from it, or even just using it, like if you've got a NuGet package, people are using it, you'll be able to provide documentation hints. Like when I've actually used anything that is string builder. So I hover over it. It's not a great example by the looks of things, because there's no documentation, because boring reasons probably. Right. Thanks for watching. Let's just commit this last few things. And while I'm doing that, let's go see if there's anywhere to raid.